So some things I want to point out about this particular part is notice there's two things being graphed here. We have the deficit, and these numbers here are measured in billions. Okay, so the deficit here, we're measuring in billions. And the deficit, if I look down below, that's the dashed line. So the deficit is this dashy line here. And then on the other side, the scale is for the debt. And the debt is the solid line being graphed here. So if I just pick on something like up above, it says the federal budget deficit for 2014 was approximately 483 billion. So let's see if I can confirm that on the graph. So they said deficit. So deficit means I'm using the scale on the left side and I'm referring to the dashed line on the screen. They mentioned 2014. Well, down here I see 2000 and 2020, and there's some tiny little marks down here. 1, 2, 3, 4, 5 spaces in between. So if you split 20 years into 5 spaces, 5 goes into 20 4 times, that means each of those marks is 4 years. So this mark here must be 2004, 2008, 2012, 2016, 2020. Ooh, that felt hard. All right, so right in between 2012 and 2016, so around right here, that should be 2014. And I'm going to attempt to trace that up and see where it hits. So if I trace that straight up, it looks like it's hitting about there. Maybe it's a little lower. According to this, it's a little lower. They say 483 billion. So that's 200 billion, 400 billion. 483 is closer to like 500 billion, which would be around right here, don't you think? So it looks like they claim the graph has that point right there on it. Pen froze. So let's make a little X marks the spot right there. So that's what they're referring to here. 2014 deficit, 483 billion. So a lot of times when we see graphs in the news, they're not going to write all the zeros for million and billion. They're just going to have a little note somewhere that says, hey, this is measured in billions, or this is measured in billions. So when I see a number like, or it sometimes even happens for thousands, there'll be a graph that'll show 200, but the fine print says, oh, that's really 200,000. And we have to fill in the thousands ourselves. So that's always something to play with when we're talking about quantitative information. Whereas if I were to look in 2014 at the debt one seems to hit much higher up, right? So 2014, oops, I meant to use the line tool. Where's my line tool? Down there. So yeah, that looks more, it's, ooh, shit. Sorry, I mean, shoot. Jinkies. It looks like it hits around here in 2014, which is close to the 18,000 billion. Ooh, what is 18,000 billion?
18 trillion.
1,000 billion is a trillion, so that would be, yeah, 18 trillion. Yeah, so this number right here, I could call it 18,000 billion. That's certainly a name for it. I could also call it 18 trillion. Okay, and a trillion had how many zeros again? 12 zeros. So I could also write that as 18 times 10 to the power 12. Is that real scientific notation? Not quite, right? It'd have to be 1.8, which means I need to up the power. So I could also say it's 1.8 times 10 to the power 13, right? So good thing in math, bad thing about math, there's usually more than one to say or do things, right? There's usually one right answer, but all of those are right. right? We can call it 18,000 billion, we can call it 18 trillion, 18 times 10 to the power of 12. Which one's the best one?
Very last one.
They're all great. It turns out that's a trick question. You know, best depends. Like if I'm telling my mom this, she is not going to appreciate me saying 1.8 times 10 to the 13th, right? My mom's not going to like that answer. But if I say 18 trillion, that'll make more sense to her, right? So it just depends on the context. If I need to do a calculation based on this, then I'm going to want one of the last two answers. But if I'm speaking to somebody, I want probably the second answer, right? That's like, there's just different ways to say and do things. All right, let's see what questions we have here. Next page, please. All right, so kind of like I was just addressing, there are different ways to state numbers. What's a simpler way to express $2,000 billion? What is a simpler way to express 18,000 billion? Right, so we could say 2 trillion and 18 trillion. Yeah, okay. Then here's where the real fun comes. But I want to show you something in between. Again, if you're in Zoom right now and you get a question, please voice in or chat. Oops. I'm trying to do something on my other screen and my other screen is misbehaving. All right, now remember I talked about the writing principle in class the other day? Anybody remember what the writing principle was for this class? It's more about how to give a good answer. Ah, there you go. Yeah. So try to get in the habit of not just writing a simple answer like 18 trillion, which is a fine answer. It works. I would take it here. But a better answer, I'm going to bring up some of my written work for this here and zoom out just a touch. So here I wrote, I think this is meets the writing standard for this class. 2,000 billion is the same as 2 trillion. I put the little dollar sign in there. They wrote the word dollars. Okay. So is the answer 2 trillion okay for this question? Yeah, it's okay. Is it a great answer? Not great, but it's okay. Something like this would be a better answer. Okay. And so I'm going to remind you of that writing principle in class. And when I grade your stuff, I might say, hey, a better way to state this might have been blah, blah, blah. Remember, this class is called Quantitative Literacy, which means reading and writing math. So I want you guys to be good math writers. What's up?
So for like the rest of these questions.
Yeah.
Since like obviously you put your work on it, if we're writing our stuff like on something else, do we have to turn that in as well?
I would recommend it. And I was going to get to that in just a minute too. Yeah. So I'm going to jump to the next question here down. I'm going to go over exactly how I did this in just a second. I got to zoom out again. Where's my zoom out button? There we go. So on this page right here for question 2A, I've written out some calculations and I've written some answers. Sometimes on the worksheet that I give you or you print or I print, there's not enough room to write everything, right? There's enough room to state an answer, but not enough room to write work. So there's a lot of time where I'm gonna have a separate piece of paper, and on that piece of paper, I'm writing down calculations or stuff to help me figure something out. Okay. So we're gonna go over this in great detail right now. Let's do it. Let's see, move this out of the way. Chat back here. And scroll down. Okay, so we're going to answer question 2A next together. Page, please. All right, here we go. And then after I do this one, I'm going to have you guys kind of split up into groups and work on these questions, and then we're going to come back and I'll double check with you. So imagine a stack of 1,000 $1 bills. Okay, they claim it's 4.3 inches tall. Okay, I don't have a stack I could measure. I guess I could go to the bank and ask, could you go back and measure a stack of 1,000s for me? But I'm going to go with the author that wrote this. It wasn't me. I think this is correct.
Stack of 1,000.
1,000 $1 bills is 4.3 inches tall. If they're fresh, crisp bills. If they're wrinkled up bills, is going to be a bit taller, right? But fresh, crisp bills packaged at the bank or from the mint, they're going to be 4.3 inches tall. Okay, so that's super useful to know. And mathematically, I can write this. $1,000 equals 4.3 inches. Right? As long as I'm talking about dollar bills, that is a true mathematical statement, right? It's kind of like saying 12 inches is equal to 1 foot. That's true, right? Yeah, and so this is a similar kind of statement. So instead of measuring in inches, we could measure things in stacks of thousands. Kind of weird, but we could do it. Yep.
I actually looked it up and
Yeah.
it's actually accurate.
Yeah, I think it's like a single bill is like 0.0043 inches thick, if you look it up. Yeah. Next, what we're going to do is we're going to imagine 1,000 stacks of 1,000, 1,000 thousands, right? So 1,000 times $1,000 is. Yeah, that's exactly what we're going to do next, right? So yeah, so right now I'm just figuring out how much money that is. So 1,000 times 1,000 is a 1 with 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6. I love multiplying by powers of 10 because you just slap zeros on. So for my answer here, I could write exactly that, or I could write 1 million. That would be an okay answer too, right? I'm just going to write it like that. So I did a little work here. Could I have done that in my head? Sure. But if you do stuff in your head, then you write down just the result. I have no idea what you were thinking, right? So please give me a little bit of what you're thinking, even if it seems totally trivial for you. Like Parker should know this. Oh, here's a good guideline for when you should write stuff down. You should write it down if you don't think I could do it in my head. So say, huh, could Parker do this in his head? I think he could do this in his head. But you'd be surprised that I still count on my fingers. I talked about that the other day. You'd be surprised at things I can't do in my head that I have to write down to confirm I'm right. But that should be like the low bar for writing stuff down. High bar, write everything down. Okay, to figure out the height, well, if 1,000 of them is 4.3 inches, and I say these guys are equal, can't I just replace that with 4.3 inches and say the answer's got to be 1,000 times 4.3 inches, which isn't as simple as adding the 3 zeros because I got to move the decimal point. So that's going to be 4,300 inches. Right.
But then you got to divide it by 12.
Oh, yeah, I'm getting there. I'm getting there. Now, has anyone ever made a mistake with a decimal point before or a zero? All the time. So guess what I'm going to do to double check that? I'm going to go whip out my calculator and make sure I'm right. Because it sucks to be wrong. Okay, I'm right. Cool.
Be right.
So be right. Yeah. All right. So next they want us to change that and they tell us 12 inches equals 1 foot. Now, you may have seen this trick before. You may or may not like it. Anytime I know some kind of fact, like this is equal to that. So for example, they're telling me, I'm just going to rewrite it. 12 inches equals 1 foot. I can turn that into a fraction called a conversion fraction. And the conversion fraction, did you ever have a doubt like whether you should multiply or divide by a given number? No, I do all the time. So what I do to confirm is I take the number I'm starting with and I write down its units. Next to it, I write a fraction. And in the fraction, I take the unit I have and I put it in the denominator. And then I take the unit I want and I put that in the numerator. And then here I know the 12 goes with inches and the 1 is feet. Since this is in the bottom, that means I have to divide. Because a fraction bar means divide. So that means this right here is the same as taking 4,300 and dividing by 12, and that will give me the answer in feet. I just need help from my calculator. So
like, they asked me to do that. How many decimal points do you want us to go back?
good question. Let me get there. So 4, 3, 1, 2, divide by 12. So 3, 5, 8, 3, 3, 3. And some calculators will show more threes than that, right? It depends on the calculator. Where do you round? Okay, so I talked about a rule the other day in class about when to decide to round if you weren't told. So like for me, looking at that, I would like to call it 358.3. But then again, do we talk about point feet? What's 0.3 feet? Okay, okay, so yeah, so maybe you do construction stuff and you're just familiar with that, or you just know it. It's not 3 inches, it's 3/10 of a foot.
What times 3 equals foot?
Well, let's double check. So 3 out of 10 is 0.3 times 12. Oops, I forgot to put the previous answer in there. So previous answer times 12, 3.6, almost 4, not quite. Okay, so my point is it weird to say 0.3 feet? The answer is, in this country, yeah, it's weird. It works great with like meters and centimeters and stuff like that, but it doesn't work so well with things like feet and inches. And so is 0.3 feet an okay thing? Yes, but it's not a common thing in the US. So what's my point? Is it a bad answer? No, it's just a weird answer.
So instead of the 3.3, which is what I got too, what would you rather split round down?
Yeah, so there's a couple of options here, right? So one is just to round and just say it's 358.3.
And then
Just go
do
for
the
it.
next question.
But what's special about going to the nearest 10th here? Anything? Not really. Why didn't I go to the nearest 100th? I don't know.
Yeah.
Yeah, so there's no good reason. Remember significant figures? We talked about that in class the other day. Yeah, so with the idea of significant figures, the number of significant digits that you start with should determine the number of significant digits in your final answer. Okay, so what did we start with here? We started with 1,000, which has 1 significant digit. That's not a big deal. The 4.3 is more of a big deal. It has 2 significant digits in it. So therefore, the best thing to do here, unless I said always go to the nearest 10th, would be to only use 2 digits. So then, where's my magic pen? Although my calculator said this was what, 358 with a whole bunch of 3s, and it turns out they go on forever if we could do that. According to the significant digit idea, we would round to that position and call it 360 feet. No, you don't have to redo it. Because on here, I do not say use significant digits, and I do not say where to round. So I will take anything that's in the ballpark. So if you told me the answer was 358 feet, I would be overjoyed with that answer.
But if I did with 0.3,
If you put the 0.3, yeah, so that would be okay too. 358.3, I would be more than happy with that.
even on and then I use
Does
that.
anybody like to do long division here? Not really. If you did long division, you would find that this comes out to 358 1/3 feet. That would be an okay answer too. All right, so it turns out there's lots of right answers to the question. What I'm looking for is something in the ballpark, right? So that would be any of those, this right here. Okay, next question.
So if you want us like on assignments that we turn in work, if we do it like electronically, if you have
Yes.
to print those out.
Define electronically.
Like I
Right on your screen?
yeah.
Oh, cool. Yeah, yeah. Send me a copy of that. I love getting those. Okay, yeah. So my daughter has one like that, and she writes on the screen, and it's cool. Yeah, and I have my little weird digital board here. Yeah, if you put this on a separate piece of paper, take a picture of it. If it's digital, include the picture. I would love to have it. If you only submitted just this right here with nothing else, I'll be slightly unhappy and I'll put a little note. Hey, I'd like to see your work next time. Okay. And if it happens regularly, I'm just going to stop giving full credit because I want to see your thought process on these things. And again, my usual mode of operation for things like this is I'm going to do all my scribble work on another piece of paper, and on here only go my cleaned up answers. And if you're that kind of person too, then give me your scribble work paper and give me your cleaned up results.
We can put it all on this if we want.
You can put it all in there if you want. Yeah, yeah, like I showed you my version of this when I was writing it in my office. I was able to fit it here this time. But once in a while on these worksheets, I didn't give enough room for me to write all the work, and I need another piece of paper. Okay, but if you can fit it neatly there. Okay, so I'm gonna pause the video right here. So we're gonna do this on a spreadsheet. So the given information was, let me blow this up one more time. There we go. I had $1,001 bills, right? And I was given that the height was 4.3. And this right here on a spreadsheet, don't type a $sign. What you do is just say, hey, format it as currency or dollars, and it'll put the $sign in there for you. Okay. There is a reason to type a $sign sometimes. I'm not going to go over that today, but that's a whole nother issue. What do I want to do with that $1,000 bill? So I want to multiply it by 1,000 for part A, right? So all I'm going to do is I'm not going to just type what the answer is. I'm going to have the computer do it. Do you remember how to get a calculation going on a spreadsheet from the other day? You type equals. That begins your calculation. What do I want to do? Well, I want to multiply 1,000 by what? The number above. Now, I'm not going to type the other 1,000 because it's above. I'm just going to click on it.
And you don't have to do the 1,000 right there. They just typed in. You don't have to put the currency on there.
No, because the previous number has the currency. It'll inherit it. Yeah. So I can hit enter, and it's going to make the calculation for me. Now, this is showing those zeros for. Do I need to see cents here?
This is the money.
Yeah, I could keep it, or I could just highlight the whole column and then decrease the amount of decimals shown. A little cleaner looking because I don't need the cents. All right. What do I want to do with that 4.3? Multiply by 1,000, right? Didn't I just write a formula here that multiplies stuff by 1,000? So this is a cool trick. So what I do is I click on the cell with the formula, and I use this magic button on the bottom and drag it over one, which is going to repeat the idea of multiplying by 1,000.
Can you just grab it all?
Not quite. So the direction you copy a formula matters, and I don't always want to do that. Now, I do agree that, oh, there's a problem here. What's the problem there?
Money.
Yeah, it's not money. So I got to take off the currency format. So I'm going to go to format, number, and just make it a number. It gave me extra decimals. I'm going to leave them for now. Oh, height. 4.3, what? Where do I put that? Okay, so it turns out you can't have the number be a number and put inches in there at the same time. The best you can do is go up here to the title and adjust the title and do something like height in inches.
But it won't all be in inches. You're gonna get the feet.
Ah, so that means I need a new column for that. So over here, I'm going to make a new column for height in feet. Feet. There we go. Okay, how do I convert to feet? Let's go back to the notes. Notes. Divide by 12 according to the notes. Yeah, so this is why I write things on paper, right? So anytime I do something on a spreadsheet, I'm always scribbling on paper too to make sure I'm doing the right thing on the spreadsheet. Otherwise, I do the wrong thing. All right, so my paper says divide by 12, and I could do that for the 4.3, so I'm going to. I'm just going to go equals. I want to take this number here and divide it by 12. Divide is the slash on the keyboard. Multiply is the asterisk. Enter. Google says, hey, do you want to fill that down? Well, it turns out I do. So I'm just going to click the check and say, yeah, please fill that down. And it gives me the next answer. Okay. All right. What do I want to do next? So that was part A here. Times by 1,000, which don't I have a formula that multiplies the thing above by 1,000? Yeah, so as Marcus mentioned before, I can just take that formula right there and fill it down. And I can take this formula right here because it just multiplies by 1,000 and I can fill it down. Now, this formula divides by 12, but isn't that what you have to do to convert inches to feet? So I'm just going to fill that down again. Pretty slick. Okay. All right. 358,000 feet. I have no idea how far that is. I think I'm going to try miles on that one. So I need another column called height in miles. Okay, now I didn't actually go over this one in class, so I better put this in my notes here. How do I convert to miles? So I need a new page. So where am I at? Let's see. I have to take the number. I'm going to use the 360 here. So I want to take my 360, that is feet, right? And I have to multiply that by 1,000. So I'm going to write down doing that because I haven't put this on paper yet. So that's going to give me 360,123. And this is a feet number again. I want to convert feet to miles. Now, the worksheet tells us that there's 5,280 feet in a mile. 5,280 feet equals 1 mile. So I'm going to set up a conversion fraction so I can confirm whether I multiply or divide. Some people just look at it and know. I'm not one of those people. So 360,123 feet. I am going to multiply that by a fraction. Where does the feet have to go in the fraction? Down below. Think about this number over 1. I want it to go in the opposite spot. Miles goes in the top. I know 1 mile is 5,280. So this means divide because it's in the bottom. So on my calculator, I need to take that 360,000 and divide it by 5,280. And that will give me an answer in miles. So now I go check to what it is, see what it is. I don't think I'm going to do it for that one or that one. I think I'm just going to start that calculation down here because I don't want to see fractions of a mile. So to do a formula, I have to type equals. And then I want to take the number to the left, slash to divide 5280. So the general rule is if a number is already on the screen, equals, click on it. If it's not on the screen, then you got to type it.
Did you say slash?
Slash, yeah, the slash is divide. Yeah, and I think that one's called the forward slash, the other one's called the backslash on a good day. All right, and now I have a lot of extra decimals. Do I really need to see all those decimals? Nah, I'm just going to take those just for the heck of it down to 1 decimal place. For just an arbitrary reason. I have no good reason. All right, so now I get 67.9 miles. Okay, now that's the now the spreadsheet is using every possible decimal place it has access to, which is a lot. Whereas on my paper, I was using far fewer decimal places. Okay. Could I fill this down again? Yeah. And here's the cool thing. Since all of them already have their behavior set in, I can highlight all of them at once and fill them down all at once. Oops, if I could grab it. And it should just work, which is cool. All right. Off we go. So here, 23,000 written in standard notation would just be a 2, a 3, followed by 1, 2, 3 zeros. That's all I want you to write. If I jump down to the next part, standard notation for this 2009 deficit, 1 billion, right? So this is going to involve some work. I'm going to write the 1, 4, 1, 2. The decimal point is going to be the comma to separate billions. Then I'm going to write the 6, 9, and then I'm going to start putting in zeros till that looks like it's in the billion spot. So, oh, I guess yeah, that's fine. So this would be 2,000 at this point. That's now a 2 million, right? With that many zeros. Ones, thousands, millions. Now the 2 is in the billions place. So that's the number in standard notation right there. Okay. The 2 here is the billion. That's the identifier. So you're going to do something similar for the others. Scientific notation. Okay. Scientific notation is some number times a power of 10. What's got to be true about the number I write here? Has to be less than 10, right? So I can't call it 23. It would have to be 2.3. So that means I would have to move the decimal point from its invisible location here 1, 2, 3, 4 times. So that must be 10 to the 4th. A lot of times when I'm trying to figure out scientific notation, I literally have to write these little loops here. I have to do it, or my brain just doesn't get it right. So if I see those loops on your paper, I could say, oh, you got a brain like me. That's all right. This one right here, for scientific notation, it's going to have to be 1.4 blah, blah, blah times 10. All right, so this one I'm going to do a little bit different. The decimal is right here. I'm just going to point to the numbers and count. I need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times, it looks like. If you're unsure about that, if you type this into your calculator, it's going to probably give you that back, because that's more digits usually than a calculator can handle. So we'll probably tell you the scientific notation. All right, so I'm going to let you guys finish the other ones there. Question?
When you're done, I'll give that to you at the end of the class.
Okay, so let's take a look at the next page. Let's see, show desktop, scrolling down. Okay, so here, the first question and the next ones after that are all looking for the same type of approach. So I'm going to do the approach for question 5, and you'll use the same approach on question 6 and 7. New page. All right, so here's my question 5. And basically, we're given some information on the top. Headline in the newspaper, Scott vetoes 69 million in a 77 billion state budget. Question, is the 69 million a large or small portion of the state budget? Okay. Now, when somebody says, is that a large or a small portion? I think back to being a kid and whether I get a bigger slice of pie than my brother, right? Sibling rivalry. Okay. And usually I might say, hey, no fair, his is like twice as big as mine, or mine's half the size of his. When we make that comparison, it's a comparison by division. My size divided by his or vice versa. So what I want to do is I want to divide these numbers to figure it out. So I'm going to take the smaller number, the 69 million, and I'm going to divide it by the 77 billion. Okay. Problem. Word million and billion aren't really compatible. I need to make these standard notation. So I'm going to rewrite this as 69, 1, 2, 3, 1, 2, 3. That's 69 million, right? Yeah, okay. And then let's do that for the 77 billion. 77, 1, 2, 3, 1, 2, 3. Billion would be another 1, 2, 3, right? Thousands, millions, billions. And I'm saying that out loud for my benefit and yours, because it's easy to make a mistake on that. All right, and then I can just whip out my calculator and do that and see what happens. But here's one thing I love about numbers with zeros and division: canceling shit, right? Come on, isn't that fun? So can I just go here and say cancel out those 6 and cancel out those 6, and it's a simpler problem? I find that immensely gratifying. So you could just plug it into your calculator, but on my calculator, I'm going to type, what is 69 divided by 77? 1, 2, 3 zeros. Calculator time. 69 divided by 77, 1, 2, 3, 77,000. My calculator is giving me scientific notation, so I got to cope with that. This is just a ballpark thing, so I think I'm going to round that to 9 times 10 to the negative 4th. And we haven't talked about negative exponents yet. We've only talked about positive ones, but it's actually pretty straightforward. So I'm going to claim that that right there is about, whenever I round, I put a wavy equals 9 times 10 to the negative 4. All the negative means is divide instead of multiply. So that really means 9 over 10 to the 4th. Okay, so that, let's see, 10 to the 4th is what? 1 with 1, 2, 3, 4 zeros. So now I'm going to go ask my calculator about that. 9 divided by 1 with 1, 2, 3, 4 zeros. Ah, it's giving me scientific notation again. Come on, Desmos. I'll go to Google. Google will probably give me a better answer. Clear. 9 divided by 10, 1, 2, 3, 4. Thank you. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. 0.0009. that. Okay, double check. This is 10,000 in the bottom, right? So this says 9 10,000ths. This is the tenths place, hundreds place, thousands place, 10,000s place. Okay, that makes sense. 9 10,000ths. Now, 9 10,000ths is pretty close to 1 out of 1,000, isn't it? And notice up here, B says that, about 1,000. Okay, so I did all that work for nothing? No, I confirmed that that statement is actually correct. Okay, so would you say the portion vetoed is a very small part of the entire state budget? Would you consider getting 1,000th a small part? Yeah, from my human perspective, it's small, so that's correct. Is 69 million about 1,000th of 77 billion? Yeah, we just calculated that. That's correct. The 69 million vetoed is a very small part of the entire state budget of 77 billion. That's true too. 69 million that was vetoed was about 1/10 of 1%. Ooh, 1/10 of 1% of the total 77 billion state budget. Okay, so just a reminder, yeah, 1% is 1 out of 100, which is 0.01, and we have 1,000th, which is 0.001, which is 1/10 of a percent. Yeah, so that right there is 0.1%. So it turns out the last statement is true too, which is the best one in terms of giving accurate, clear, complete information.
So you want it, so, I mean,
This-
there is no long answer,
Well, it turns out there is here, because this question says, what's the best of these 4?
so for D.
D is the best one. Yeah,
Number D.
they're all correct, but number D is the
Yeah,
best
number
one.
D is the best.
Yeah, number D is the best answer here. Okay. That was intense. So what you're going to do for the next few questions is you're going to look at the 2 numbers given and do a division and then make a statement, kind of like question D, for the next 2 questions. With that in mind, question number 7 just gives you 1 pair of numbers to compare, right? So you're just going to do a division on those 2 and then make a statement like D about it. Question 7, you only need to pick one of those numbers in this list to compare to the 68 billion. You don't need to do all of them. Pick any one of those there, do your division comparison and write a sentence, okay? Do your best sentence. If by Monday you don't think you have a good sentence, then come and see me before you turn it in officially. If you're a Zoom student, we'll talk or email or do a private Zoom. Do your best.